Okay, it's Roger, Mudfossil University, and it's going to be electron flood single dipole particle theory. That means there's no protons, there's no neutrons, none of that stuff. Every single thing there is literally the smallest particle that we know of, which is the electron. Now, if you read the paper, it says there's 1,836 of these electrons. Just like every one of these particles would be an electron, it's 1,836 of them make a proton, 1,837 make a neutron. Then they all glob together and they create the nucleus, and then each one, some of these other additional particles go in their orbits around. Now, I am going to demonstrate this. Of course, you can read this whole paper, and it goes into pretty good detail about what photons are and what electrons are, and that everything literally is made of electrons. And the current model says there's one large, solid, positive, huge thing that has one electron volt and a proton, and then one tiny, tiny, tiny little particle they don't even care about is the negative electron, and that has one electron volt. It's just that it's negative, that one's positive. It doesn't make sense. Current model, large, solid, positive, only one electron volt, and a tiny negative still has only one electron volt. And that has no way to account for the isotopes. None whatsoever, unless you can break up those protons. And that's what I do. That's a proton. It has 1,836 electrons. All right? We're going to go into great detail about this. And before we do, I'm going to just show you in light experiments and show you these particles. Because if you don't see them, it's all, just guesses, really. I'm going to show it to you. Okay, I'm going to call this the Roger 3-step. Here's the first step. This is light, and these are the kind of light things that I am going to show you in a second. But how did we get these pictures of light? I'm going to show you what the setup is. We're going to be going into the light in great detail, all the pictures and how they interact. But this is all this is this Bosch laser, GLM 15. It's a construction laser. It pulses red laser light. It comes out of here, and there's two round metal drums right in front of here. And they create a venturi. And a venturi is nothing more than it forces it to restrict itself and crush into itself. What this does is these particles, as I will explain, have a huge region that they control. There's nothing in there other than magnetic influence. The particle is in the dead center, but in the magnetic influence is huge. So when they're all restricted together, in this venturi, they become highly agitated. And you will see that. And they spray out of here in extreme, violent, chaotic spewing out. And at such an extreme speed, they cannot interact with the environment that they're coming into because they are so accelerated. And you'll see the acceleration. And that acceleration starts to slow down, and then you get these Higgs fields. You'll see them in, this is my representation. Now, then it will turn back to red laser light as it slows down and finds its way back to its normal speed within this particular medium. So, laser, pins that restrict it and create a venturi, bosons, these are bosons spraying out of here. This creates white plasma, which is Cherenkov, turns into bosons. They spray out there, smash into the atmosphere, and illuminate it and fluff it up into these Higgs fields. And they only last for 2 cycles that I have ever seen. And then they come back to red. Now, these are the light shots, and now I'm going to show them to you each one at a time, and I'll explain it to you. Before I explain it to you, I'm just going to give you a lay of the land. That's just straight out of the laser. That's accelerated. That's coming out of the accelerator towards us, the Higgs fields. This is something very strange. These are the actual particles. That demonstrates the right-hand rule and the followers of the main particle. let's look at them one at a time. That, my friends, could quite well be a photon. And what is a photon in the electron flood realm where there is only a single particle? The single particle still has a positive negative, don't forget. So that is a negative, that's a positive, let's say. Well, that's a negative, that's a positive. So what do we have? If you split it down the middle, you would have two particles. Or if you split it down the middle this way, you would have two particles. And you could see they are trying to interact to some degree. And there may be some form of a torus going on here. I don't really know, to be perfectly honest with you. I am sort of assuming these are two bar magnets just like these are, snapped together. And they're probably spinning or doing whatever they do, and it has to be that they always seem to have this alignment with this way towards Earth. So there must be a negative to them and a positive to them, because the Earth is a positive attractive source. It sucks electrons down to the Earth as fast as it can get them. Electricity, lightning, static, every single electron goes to Earth. Now, I believe when this thing crashes into other molecules, primarily water, it seems to me, they split apart. One of them goes flying off, spinning, 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 creating these polarized fields as it goes. Exact same fields that are created inside of a wire as electricity goes through. If you could follow that field, it would be a round circular field following the electricity. It's called the right-hand rule. Spins this way, goes that way. Now, let's look at this a little deeper. So these are the particles that I'm basing my theory on. And these are the particles that split apart when they crash. It's called the photoemission effect. Well, when it crashes, one of them takes off and creates a field. Now, I'll show you that right now. My friend Renz in Polynesia sent me this picture. Hold on. And of course, all this stuff, the pictures here about Rodney Warren. And he came up with this accelerator, Venturi, quite by accident. And I worked with him for a very extended time, at least a year or more. And graciously, he shared his discovery, and that made my atomic theory able to be presented in a very, very supported way. As far as I'm concerned, it's pretty damn supported. So here goes. Now, this was my friend Renz, and he had just his thumb up like this. Now, that's the Higgs, and it is twisting because it's only a half a Venturi. You see it twist and twist, it's coming off, but that is a white Higgs, and the reason it's white is because you're in full spectrum light versus red laser. Now, what's happening here? This, to me, looks like leptons. I can see blue, then green, then red. Blue, green, red, blue. And the red keeps splaying out further because the red is the longer frequency light. That's what they call leptons, and you know, blue, green, red. That's what's supposed to be the leptons. Short, a little longer, longest. Now, let's look at the other thing that Renz caught. Now, when you casually look at that, you really don't see much, but when you take a quick, good look at it, these are all Higgs fields. Now, why are they all there? There's moisture in the air. That moisture, I believe, is being concussed. And the result is the Higgs fields. And I believe that moisture is being warmed up. And what is warming up? Warming up is accepting electrons. So, I believe one of the electrons is being absorbed as heat, and one of them is cascading away as light. Now, where that one will go and what we will do, I do not know. I assume, I'm pretty sure we're only seeing them because of the immediate impact here. As they go further out, you don't see them anymore, but they are still going to be in their electronic configuration until they find somebody to bond with to create heat, more than likely. All right? Because all they are is electrons, and electrons are only heat and cold. That's all they are. Until you add them together and create a product. Once you have that product, then it's additional electrons. In other words, once I have this, I got my electrons, I got everything I want, it's created a structure that is what it is. But I can heat it up, I can cool it down, and then when it comes back to what it was before, it's back to what it was at the same temperature. What did I do when I heated it up? What did I do when I cooled it down? I drove electrons in, extra electrons, more electrons than it wanted. They will flow back out as cold. Cold flows out. If you open your refrigerator door, you see the cold flowing down because it is vaporizing the water molecules. It's turning them into, well, it's not vaporizing them, it's condensing them. And it's cool. When it cools down, there's a lot of moisture in that air, right there in front of the refrigerator door. And you get a lot of cold hitting that moisture. It turns it into a cloud, literally. You can see the cloud fall to the air. That's electronic transfer, and that is all heat and cold is. Nothing more whatsoever. Not anything whatsoever different. Not a single bit is not electronic transfer. It's going in or coming out. If it's going in, it's heating up. If it's coming out, it's cooling down. And if it's so excited, it will emit electrons in various different ways and different intensities. All right, so this is it's one particle world now. Okay, back to part 3. Don't forget, the red laser accelerated through the Venturi. I'm going to call that Cherenkov radiation. I'm going to call this bosons. I'm going to call these Higgs. And it goes back to its red laser light. Now, let's watch all these things happen. Okay, we're going to start right here. Bip, 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 bip. That's what this laser does. What are we seeing? Obviously, this thing isn't shooting basketballs out of here. It's shooting one tiny dot, which is the light. And I mean it is a dot, and you will see it. And it's going bip, 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 bip. Well, when it comes out of there, it might only be this tiny dot, which is almost imperceptible, but it does magnetically influence a region approximately this big, literally. And as it goes through the air, everybody else has to get out of the way. When they do, they luminesce. This is no difference whatsoever than the wake of a boat or the wake of a jet fighter crashing through the sound barrier. These particles here are all sort of taking on a little glow because they're being pushed. And the nature of electrons is when they concuss with anything, another electron, the wall, my hand, whatever it is, they give off a little bit of heat, and as they get stronger and stronger giving off, it glows more and more and more. These are weakly they're being sort of compressed and giving us sort of a glow. These is much more of a glow, and when you see the Cherenkov, you're going to see glow. Okay, you remember that wave that was coming through here. Well, now it's being accelerated. It is absolutely being accelerated. There is nobody on the face of the planet could possibly deny that is accelerating. And what else do we see? We see the particle itself breaking free of the restricted space that it was in, because now it is accelerating into the Venturi, which is created by these two steel drums that I showed back here. Okay, so here we are. There's the laser light coming through. And what it is just two steel drums right in front of the laser. and these drums create this spray. All right, so everybody good with me so far? We're going to see the Higgs in a minute. They start creating after here. But this white spray here is plasma. I mean, it's quite obviously plasma. Now, what is plasma? Plasma is literally electronic chaos. They call it anything they want, but it's particles that are in so much chaos that there's no structure to them anymore. They're not glued together with anybody significantly. They're just all just in turmoil, like boiling. And in this case, in electronic flood theory, that's a lot of boil. There's a lot of things can happen here. Now, when they come out of here, they're still electrons. These are only electrons. When they come out of here, they're going to reform. So let's see what they do when they come out the other side. But before we do that, I want to explain just the total dynamic system here. Absolutely phenomenal what Rod has captured. So let's just take it from the interaction. We know that it's coming through, zoom, and it's just crushing each other, and as it does, they glow more and more and more, and as they all try to get together through this, they are crushed into plasma, which is total chaos, head to head. They want to have regions way around, like one guy wants to be way over here and another guy over here. Well, now they're all like this coming through. Do not like it. Do not like it whatsoever. All of their energies are just... Nobody's attached to anybody at this point. That's plasma. And fusion requires plasma. This is a passive crusher, and the particles that fuse are just bigger pieces. What I'm using here is these. Boom, that's a zillion of them coming through here. But what CERN is using is these. They're hitting them head on and just getting a mess, okay? If they could put them through this, like I am, in these Venturi crushers, and tune it, you could tune them, you could have different materials, titanium, whatever you wanted, and just play to play. I'd have a blast. I mean, Rodney, he'd be in ice cream heaven, man. I mean, he just is off the wall doing this stuff. It's fabulous, fabulous, fabulous researcher on light. Now, so what would CERN do? If they put these through and created this, when it came out the other side, they would now be in all kind of disarray, and when they came back together, instead of being heavy particles, which they would put through, which is deuterium and tritium, which are heavy hydrogens, they would rearrange themselves to become helium. That's the story. Now, if that happened, the heavy part of the hydrogens would be excess. Excess in my world is just a ton of extra electrons. And those extra electrons go into conductivity, or whatever you do with them, you harvest them to do whatever it is, heat or conduction, whatever you're using them for. But you'd have to obviously have a vacuum chamber. Anyway, let's go past that. But that is the potential that I'm talking about in this type of understanding. If you don't understand the nuclear core of an atom, you're never going to get to fusion. You're never going to get any of the things they're talking about. You know, they're doing a good job is what they got. And they're seeing the things they're seeing, but they can't explain them. When you get into these isotopes, way in the middle of these ranges and these immediate decaying cascades, I mean, it's just phenomenal. And that is how biology works. I'm going to tell you that right now. That is absolutely guaranteed. The number of enzymes in your body and coenzymes and cascading enzyme cofactors is phenomenal. Every bacteria, basically, and they live in membranes in your body, and your membranes are thick, thick, thick. They think they're paper thin. Well, there's tons of bacteria living in them, and if you kill that bacteria, you are in harm's way, and you will not have your enzymes. to do what they're supposed to do and breaking down all these little particles, which are, the only reason they can break them down is because of electron flood theory. There is so many particles available to break down and to fuse and to cascade and create one particle to the next. And they can transmute. Bacteria and enzymes can transmute particles and make new particles. It's been proven. They've done it with potassium, turned it into calcium. So, and that's only by bacteria. It's in plants. Anyway, let's talk about this a little more. All right, I run off on these different tangents, but I want to bring, they say teach when you can teach. And it's a teachable moment when I'm saying something and something else comes into play. So that's where I go with the stuff. Now, what are we looking at here? Here's another teachable moment. What do you see here? Look way out there. See, this is what I did. I love this kind of stuff. Now, you see what you got over here? You know that there was this huge impact here. And why are these faces of these waves? These are just like these waves. Why are these faces glowing? The reason is this is radiating backwards. This is called reverse EMF. Right? And what is EMF? Electromotive force. This is forward electromotive force. This is reverse electromotive force. It's kicking back. And how can I say that? Well, here's all I can say. If you look at the waves, you see these waves? That's a reverse, because they come back in balls. These things are like balloons. And you see these little tiny particles down here, all the little white ones? They're not white really, they're yellowish looking, but those are concussed. Let me see if I can get any closer. See, those are electrons that are free-floating ether electrons that are in the air. The things that collect on you for static, discharge to ground, those are what's glowing here. You see over here, they're sort of pretty glowy, and then they start to fade and fade and fade and fade and fade. That is the nature of light. It impacts it less and less. But this is reverse light. It's coming this way, and now it's reversing. And I'm going to tell you something else. Rodney told me that occasionally at this venturi, which is 2 steel pins, strictly light, from this little red laser light, he could hear it sizzle. All right? Think about that for a second. Slow your little mind down and think about that for a second, my friend. Because what does that tell you? Here's what it tells me. Light is breaking the speed of light barrier. If light can create sound, I'm looking at it like the jet crashing through the sound barrier. Now, what is that sizzly, crackly sound that Rod heard? I'm trying to figure that out. And today, I want to just make a point. I don't have to tell you everything there is to know about light. My allegation, my claim, my statement is that everything is made of one single particle. Now, that's enough to claim. And I'm showing a lot of evidence to go along with it, and I'm going to show it as much as I can. But when I know what's going to happen, and it has happened already, the attacks will be strong, and it'll just be everything. Instead of looking at what I'm presenting, it will be, well, I don't have this or I don't have that, whatever it is. Instead of looking at the evidence, it always goes that route of how we can just shut this guy up. So I don't shut up, and I ain't going to shut up. So here we go. We're going to go and look at what this accelerated light showing a particle. So already we know that light can accelerate, and who could dismiss that? You can't. We can see it's a particle. That's not dismissible either. So we can see that it's accelerated. We can see it's turned into plasma. We can see it's coming out of the other side here in an extremely aggressive manner, which is Cherenkov radiation at this point. And I will show you why I'm making these statements. And then we saw the reverse EMF. We saw the glowy little particles in the air, which are free-floating electrons. As I said, will collect on you. They are the things that disassociate from light and all the other things. They are literally heat. And in certain conditions, they will collect on you. In other conditions, it will be dry and they won't collect on you. They appear to need certain conditions with water molecules. That's another thing we'll get into. And again, I'm not trying to prove everything in the whole universe today. I'm going to get close. But it's not going to prove everything. And if you got something you want to talk about, let's talk. Just don't shut the doors. This is the reason I say we have created electron-neutrino electron showers. You'll see. The high-speed particle, the voltage of that particle is higher than the normal voltage. When it crashes into its neighbors that are in this unrestricted space, they just explode and they go flying into these cones. And really, it's literally identical to what CERN does. No difference whatsoever, only we use the tiniest particles. And I'll show you this in a second. The Cherenkov radiation from the electron shower produces electron-neutrino events, produces multiple cones, therefore a diffuse ring in their detector array. Now, what is CERN doing? CERN is doing this. They're using the big chunks. It comes in and it just goes boof, and this is the cone they get. Now, let's take a look at what we're getting. Well, it's hard to claim that that's not a electron neutrino shower. I mean, it is a shower of these electrons coming out of there. They were light, and in my world, when they came through there, they came through and split apart. And these are the split apart, sizzling particles. They call them bosons. They are going too fast because they've been accelerated. They are Cherenkov radiation, too fast to interact with the space that they're in at this moment until they slow down enough, until they fluff. And at that point, these are what they call charged particle carriers. And they come out of here spinning like hell. And when they hit the electrons in space, they just do this fluffy spin. And that's what creates all of these fields. And then they do this. No, they come out of the accelerator over there in that plasma condition, and then they settle down to this. And I think I showed that in the green, and it comes in red too, and then they come back to like this. These are those coming back to here, is what it appears to me. And again, it's back-to-back electrons. That's all I can say. When they come out of here, I don't think they're back-to-back. I think they're just all in globular, this and that. And then they sort of hit together, and then they turn into electrons of light, or photons. Well, actually, at this point, they're back to photons. There are electrons over in this area, and they turn back into the photons, and then they go back on until they interact with some other molecule that wants to accept one of those electrons and spit one out. That's what it seems to me. And they heat things up. That's what they do. Light heats things up. And when it heats things up, it's at absolutely no question whatsoever, it is adding electrons. No question whatsoever. Anything that heats up has electrons being added. If it's light coming down and hitting it and light and warming it up, it contains electrons. It's just loaded with electrons. That's all it is. Now you saw the red electrons. These are the green ones. Now they come out a further distance, but it's the same looking particle to me. I don't see any difference. Maybe you do, but I don't. Now I had another guy, Fabian. Hold on a second. Well, I made the statement that we're doing exactly the same thing as CERN, only we're not using expensive equipment. And we're using one particle versus their chunk like this. Now, they are coming head on with two of them, boom, and they get all this debris. What are they seeing? They're seeing the exact same things we're seeing. They are seeing these circular, polarized Higgs fields. Now, why are these like here and all these little tiny little spits and this and that here and there? Well, these are more or less chunks. These are the big, I mean, because you can do the same thing with chunks as you can do with one or two particles. And this is exactly what's happening. They have just a mass of things going on. And you're going to get a few that are going to be the stuff that we are looking at, which is the single particles. That's what we're starting with, it's these. They're starting with these, with a whole ball of them together. Well, they got to separate them out. When they do, they don't really want to be separated. Most of them will stay together like this. They'll come flying off here in these circular fields because they don't want to leave each other. Right? And some of them will get away, and that's what you got right there. That's called Higgs fields from CERN. The other ones are Higgs fields from Rod. The only thing different between what Rod has here and what CERN has is these are more elegant, they're more defined, they're more obvious, and they also did that. And what is that? In my world, that is a reverse spinner. They should be spinning to the right. That one's spinning to the left. And when they spin to the left, it appears they gather their field instead of splaying it outwards. They pull it in. No field surrounds that. It is white. Fields surround every other particle. They are not white. Why? Let's take a look. That's that particle. It has a structure to it, and it has a form, and it's cascading down into what appears to me to be another Higgs field similar to these. Now, as it's doing that, this little light trumpet is issued. Now, why? What will that do? Will that fluff up? Will that stay what it is? What is going on there? I have no clue. Is that antimatter? It could be. It came through the particle accelerator crusher at the exact same, should have been exactly identical to what all the other particles were. However, if it came through and for some reason, when it disassociated, it didn't spin in the correct direction, it spun the wrong direction. There's a right-hand rule. Anybody understands that you go like this way and the electricity's going that way. And the same thing with light. If it's coming this way, the field goes that way. So, that is smaller than light in my world. Maybe it is, maybe it isn't. I don't know. But this should have been the same as whatever the particle is in there. And now, whether it gathered some more and it's sloughing some off and becoming one of these, I have no idea. These are the kind of things that you can't hold me accountable for. I can't get that deep. It's as close as I can get to showing you the depth that I have. And I'm just trying to account for everything. I think I'm accounting for a lot of the stuff here. So, that is, in my world, the smallest particle that's ever been seen. It's another fabulous shot by Rod. This is the particle, just that. This shows you how the particle travels. Comes out of the laser, spinning to the right, forward, and as it does, it cuts in behind the Venturi. It's coming through the Venturi. Single slit Venturi. Spinning, you see it spinning, 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 spinning. And as it comes out this side, it spins over to this way. So it comes out over this way, and some of them are going to hit from here, some of them are going to hit over here, hit over here, hit over here, wherever they hit. But they're going to all be doing this. And if you look at this, any machinist will tell you that is a drill bit. Right? That's exactly what you're looking at right there. Now, and it's screwing light through that slit. What you're seeing here is one of the particles coming through, and it's expanded here and collapsing up here means obviously slowing down, and these fields that surround it are being turned on by this spinning particle. And as we saw, there was fields, round fields surrounding the particle as it went. That's called the Higgs fields. And I believe that's what we're seeing here. That's the main particle, and these are the surrounding illuminated particles traveling with it. Everything is moving together, so it's one like this. It's really all in movement, and we're capturing it as a length of movement. Well, I could still be wrong. I mean, you know, obviously I could be wrong about everything, but my last thought was that there was an electron that got sucked to the Earth and a positron that was pushed away from the Earth. And that could still very well be. Or it could be two electrons back to back. And that's all I can say. I had protons and neutrons are stable, that 1836, 1837 particles. And the universe is made only of these electrons and positrons. That's when I had two particles. And they are still within resonance frequency, same thing, but only it was 918 and 918. And for the positron, electron, positron, for the neutron, it was 918 and 919 of the electrons. So I'm going to leave it at that. Roger, Mudfossil University, Rod Warren, fabulous discovery of the Venturi. And we're just going forward with this. I want to see if they can do anything with this. And anyway, that's my atomic theory, and I guess we just leave it at that.